Somewhere in America right now, a locomotive built in 1941 is pulling freight. Not in a museum, not on a heritage line. In a working rail yard, earning revenue, while million-dollar modern engines sit dead on nearby sidings, waiting days for a replacement circuit board. The ALCO S2 switcher is over 80 years old. The company that built it collapsed more than half a century ago. There is no factory support, no dealer network, no software updates, and yet dozens of these machines simply refuse to die. The answer begins with a world war and an engine that was never supposed to be immortal. In 1941, the American Locomotive Company found itself facing a new kind of war, not just against foreign powers, but against the limits of American industry itself. Rail yards across the country were choked with freight, ammunition, and raw steel. The U.S. War Production Board rationed every pound of iron and nickel, forcing manufacturers to reuse tooling, stretch old designs, and squeeze more work from every machine. For Alco's engineers, the challenge was clear. Build a switcher that could survive relentless punishment, run on whatever fuel or oil was at hand, and keep moving when spare parts vanished overnight. A retired Alco engineer recalling those days described the mandate as, "Make it simple, make it strong, and don't let it stop." The S2's design year, 1941, meant every decision was shaped by the realities of wartime scarcity. Instead of inventing a new engine from scratch, Alco's team leaned on the existing 539 tooling, a move that saved precious time and resources. But this wasn't just about convenience. The old 539 block was already known for its thick castings and forgiving tolerances. By turbocharging it, engineers could boost power without adding complexity or risking reliability. The War Production Board's allocation limits meant that every casting, every gear, had to justify itself. There was no room for excess, yet the S2 ended up with more metal in its frame and engine block than most rivals. The result was a locomotive that could take a beating and keep working, even when maintenance was little more than a grease gun and a hammer. Alco's design choices, oversized bearings, simple gear trains, and a low-speed, high-torque engine weren't just responses to wartime pressure. They were the foundation for a machine that, by all logic, should have worn out decades ago. Yet, against all odds, it didn't. The story of the S2's impossible longevity begins here, in the crucible of World War II, where durability wasn't just a feature, it was a necessity. Inside the S2's hood sits a prime mover that defies modern expectations, a six-cylinder turbocharged diesel known as the ALCO 539T. At first glance, it looks almost primitive, but every piece of this engine was built with the kind of heft and simplicity that seems almost reckless by today's standards. The cylinders themselves measure 9.5 inches across with a 10-inch stroke, giving each piston a travel distance that would make a car mechanic blink. The entire block is a single, massive, sand cast iron piece, with wall thickness averaging 1.5 inches, far more metal than its EMD rivals ever carried. The 539T's crankshaft is forged steel, supported by 4 oversized main bearings, each nearly 2 inches in diameter. These are not numbers chosen for speed, they are chosen for survival. The engine's red line is a modest 1,200 revolutions per minute, but in real yard service it rarely spins above 800. That low speed, paired with a long stroke geometry, means the pistons and rods move with a deliberate, almost lazy rhythm. Yet on the factory dyno, the 539T delivered a flat torque curve, an astonishing 6,250 pound-feet at just 800 revolutions per minute. That is more pulling force than most competitors, and it arrives without drama or strain. Turbocharging came courtesy of a General Electric TD2 unit, bolted right to the exhaust manifold. At full load, it pushes about 7 pounds per square inch of boost, enough to wring 1,000 horsepower from the 6 big cylinders. But the real secret is not in the power, it is in the way the engine shrugs off abuse. Generous tolerances allow for wear and field repairs. The oil system holds 12 gallons, feeding dual pumps and a dedicated line for the turbo bearings. Cooling is handled by oversized radiators and a high-capacity water pump, keeping temperatures steady even after hours of hard switching. On paper, these specs seem almost excessive. In practice, they created a machine that could run day after day, year after year, with nothing more than basic care. It is not just the numbers, it is the way those numbers add up to a machine that refuses to die. Numbers alone can't explain how the S2 keeps running when so many of its contemporaries have vanished. What sets it apart is not just what's on the spec sheet, but how those specs were brought to life through a philosophy of overbuilding that feels almost alien today. The engine block, for example, is not merely thick for the sake of strength. It is cast with walls averaging 1.5 inches, a dimension that let the metal absorb decades of thermal shock, vibration, and even corrosion without warping out of round. That extra iron wasn't a luxury, it was a shield against the unknowns of wartime fuel and rough handling. Alco's engineers didn't chase tight tolerances or squeeze every ounce of efficiency from the 539T. Instead, they built in forgiveness. The piston-to-cylinder clearance was set at 0.010 inches, loose enough to allow for expansion, dirt, and the occasional botched field repair. Main bearings were oversized, and the crankshaft's 4 massive journals could tolerate the kind of misalignment and shock that would sideline a modern engine. Even the camshaft and accessory drive were simplified, stripping out unnecessary gears and linkages, so there were fewer parts to fail, fewer spares to stock, and less to go wrong when a tired shop crew was working by lantern light. Running at just 800 revolutions per minute, the engine's big, slow-moving parts faced less stress than the high-revving diesels that would come later. Lower speeds meant less friction, less heat, and dramatically longer lifespans for everything from piston rings to connecting rods. This wasn't just conservative engineering. It was a deliberate bet on longevity over speed, on making a machine that could survive neglect, cheap oil, and the grinding realities of war and industry. The result is a locomotive that shrugs off abuse others can't survive. Maintenance logs from the 1950s show S2s running 20,000 miles between major overhauls, a figure modern shop managers still find hard to believe. In a world where most machines are built to a price, the S2 stands as a relic of a lost era, proof that sometimes the secret to immortality is simply refusing to cut corners. Out of the millions of locomotives built in the 20th century, the Alco S2's numbers tell a story that borders on the unbelievable. Between 1940 and 1950, Alco's Schenectady plant and its Canadian partner turned out roughly 1,502 S2 switchers, each stamped with a serial number and tracked in ledgers that still survive in railfan archives. These were not rare machines. In fact, at the height of wartime production, Alco delivered more than 200 S2s in a single year, with a total output that rivaled the biggest diesel programs of the era. For a decade, S2s poured out of upstate New York and into the yards of every major American railroad, as well as steel mills, ports, and military bases from coast to coast. But here is where the numbers start to defy logic. 80 years later, more than 180 S2s are still running, hauling freight, shuffling grain cars, or idling in museum yards. That is a survival rate of about 12%, a figure that dwarfs the typical fate of industrial machinery. Most locomotives from the 1940s vanished decades ago, scrapped for parts or sidelined by newer models. Even the celebrated EMD switchers, produced in greater numbers and backed by a stronger dealer network, have largely disappeared from daily service. Yet the S2, designed in the shadow of war and built in a vanished factory, continues to appear on active rosters and shortline payrolls across North America. The raw math does not add up. Machines built for a 30-year life are still earning their keep at 80. Rosters compiled by the Diesel Shop and Railfan Quarterly confirm that at least 140 S2s remain in commercial use, with dozens more restored for heritage runs. No other American yard switcher of its era comes close. In an industry where obsolescence is measured in decades, the S2's numbers stand as a quiet rebuke, a statistical anomaly that refuses to fade away. Steel mills, grain elevators, and short-line railroads have become unlikely sanctuaries for the Alco S2. In these places, the rules that govern modern railroading seem to bend. The S2's high tractive effort at low speeds is perfectly matched to the demands of switching loaded grain hoppers or dragging strings of steel coil cars through tight, uneven yards. Unlike mainline diesels that chase speed and horsepower, these old switchers thrive in the slow-motion grind of industrial work, idling for hours, creeping forward, then shoving a cut of cars with torque that never seems to run out. On the Minnesota, Dakota, and Western, 5 S2s still shuffle freight every weekday, their engines thumping steadily through the snow and heat alike. Mechanics there say the same thing as their counterparts at the Toledo, Lake Erie, and Western. If it moves, it earns. If it breaks, we fix it. The economic logic is hard to dispute. Buying a new Tier 4 switcher costs upwards of $2 million and comes with a maintenance contract that can tie up a small railroad's cash flow for years. An S2, by contrast, can be bought for a fraction of that price, and any competent shop can keep it alive with hand tools, a lathe, and a stash of used parts. A current shortline owner, Rick Donnelly of the Georgia Central Railway, keeps a battered S2 at the heart of his operation. He explains, "We run it 6 days a week. It's slow, but it never lets us down. I can teach a new guy to maintain it in a week. If something cracks, we weld it. If a bearing wears out, we pull one from the donor in the barn. The new engines? If the computer goes, you're dead in the water." In these hidden corners of American industry, the S2's old virtues, simplicity, heft, and brute reliability are more than nostalgia. They're a business model. For operators who can't afford downtime or dealer-only repairs, the S2 isn't just a relic. It's a lifeline, built for a world where machines had to outlast the people who ran them. In the world of the S2, survival isn't just about tough metal or forgiving tolerances. It's about the people who keep these locomotives running long after the original builder vanished. With Alco gone since 1969, there is no official supply chain, no parts catalog, no helpline. Yet across North America, S2s still move freight, thanks to an underground network of ingenuity and grit. Shortline owners and shop crews have turned cannibalization into an art form. Retired S2s, stripped of their badges, serve as organ donors, yielding crankshafts, gearboxes, turbochargers, and even chunks of frame. In Georgia, Rick Donnelly's crew keeps a row of derelict units behind the shop, each one a potential savior for the working fleet. When a bearing fails, they do not wait for a shipment. They pull the part from a donor, machine it to fit, and have the locomotive back on the rails by sundown. For what cannot be salvaged, there is fabrication. Modern CNC lathes, guided by digitized blueprints from the 1940s, turn out new pistons, cylinder liners, and cam followers. Small shops from St. Louis to Portland have become the new lifeblood of the S2, producing runs of parts in batches of a dozen or less. Some even share finished components through informal swaps. One shop's surplus becomes another's lifeline. There is no central authority, just a patchwork of mechanics, machinists, and rail fans who trade knowledge and spares through phone calls and online forums. The result is a closed-loop ecosystem, where the death of one S2 can mean the survival of 3 more. No modern locomotive, with its sealed electronics and proprietary software, could hope for such afterlife. Here, repair is not just possible, it is expected, and the machine's immortality is a community project. EMD did not just beat ALCO on the sales charts, they rewrote the rules of the locomotive business. While the S2 was earning its reputation for brute survival, EMD switchers swept through the market on the strength of something far less romantic. A dealer network so vast you could find parts and service from coast to coast. EMD offered more than horsepower. They sold railroads. Peace of mind. If a railroad needed a new engine, EMD could deliver, fast. If a part broke, a replacement was often just a phone call away. Their credit terms were generous, letting even small operators buy new power on installment plans, instead of scraping together cash up front. For railroad accountants, that mattered as much as horsepower or torque. Standardization became EMD's secret weapon. Every SW1, SW7, or SW9 shared the same basic components. Mechanics did not need a shelf of one-off parts or blueprints from a vanished builder. Training a new shop crew was simple. Learn one EMD and you could fix them all. For big railroads, that meant fewer surprises and more predictable costs. For EMD, it meant repeat business and a lock on loyalty. And yet, even as EMD's numbers climbed and ALCO's faded, a stubborn core of operators clung to their S2 locomotives. The market had spoken, but not everyone listened. Some saw the value in a machine that could be fixed in-house, with no dealer contract and no waiting for factory approval. EMD may have won the sales war, but the S2 earned a different kind of loyalty, one rooted in the freedom to keep a locomotive alive on your own terms. A modern switcher can cost more than $2 million, yet in some yards it spends more time waiting for parts than moving cars. The culprit is often not a broken axle or a cracked block, but a failed electronic control unit, a black box smaller than a shoebox, and loaded with proprietary code. When one of these ECU units goes down, the locomotive's engine will not even crank. Mechanics call the dealer, run a diagnostic, and then wait. Lead times for a replacement can stretch from 4 days to 12 weeks, depending on the model and the backlog at the factory. In the meantime, the locomotive sits idle, sometimes blocking a siding, sometimes gathering dust in a shop bay. Maintenance logs from shortline operators tell the same story across the country. A Tier 4 switcher built to the latest emission standards can be sidelined for weeks by a failed sensor or a glitch in the after-treatment system. The repair itself is rarely complex, but the parts are locked behind supply chains, software keys, and dealer-only service calls. One operator reported a 2-month delay waiting for a DEF dosing module, a part that costs less than a set of S2 piston rings, but can only be sourced from the original manufacturer. Contrast that with the S2. When a relay fails or a bearing wears out, the fix is measured in hours, not weeks. A mechanic with a lathe and a set of wrenches can have the locomotive back in service by the end of the shift. The S2's biggest downtime is not waiting for a part to ship from overseas. It is waiting for the paint to dry after a field repair. In a world obsessed with efficiency, the S2's brute mechanical simplicity has become its greatest advantage. The paradox is hard to ignore. The more advanced the locomotive, the longer it can sit dead, waiting for the future to arrive in a cardboard box. Every surviving S2 owes its life not just to thick iron and forgiving tolerances, but to a living network of people who refuse to let these machines fade into history. In towns where the last ALCO dealer's sign rusted away decades ago, volunteer crews and preservation societies have become the new custodians of the impossible. Their rosters read like a roll call of the determined retired machinists, railroaders' children, weekend welders, each contributing a skill or a spare part to the cause. The restoration of AT and SF2350 stands as a testament to what is possible when old engineering meets modern ingenuity. Led by shop foreman Carla Jennings, the Railtech Fabricators team tackled a failing set of original cast iron cylinder liners. Instead of accepting the usual cycle of patch repairs, they sourced digital scans of the 1945 blueprints and commissioned nickel-borated steel replacements. The process demanded months of late-night machining and metallurgical testing, but the results were impossible to ignore. Mean time between failures jumped from 162 hours to over 1,200 hours, a seven-fold leap measured in logs, not just in legend. Digital manuals, scanned and shared across the country, now guide every step, from torque specifications and wiring diagrams to the liner installation sequence. These documents, once locked in factory vaults, have become the backbone of a restoration culture where knowledge is as precious as any part. In this world, the S2 is more than a machine. It is proof, rebuilt and running, that durability is not just a memory. It is a choice, renewed every time a crew fires up an engine that should have died generations ago. Today, the S2 outlasts both its maker and its rivals, a relic that exposes the uncomfortable truth. Machines once built to endure are now engineered to expire. As modern locomotives grow more complex, yet less dependable, the S2's persistence is not nostalgia, it is a challenge. What if durability was not an accident, but a choice we stopped making? Thanks for watching. What does real progress mean to you?